A gentle introduction to programming. You already think like a programmer. You just don't know it yet. I know the world has probably whispered that programming is hard, that it is for certain kinds of people, that you might look foolish trying to learn it. But I am here to tell you something different. Programming isn't confusing at all. What's confusing is how it's usually taught. Like handing someone sheet music before they ever heard a song. We're going to do this differently. We're going to start with something beautiful and real, something you can feel in your bones. The secret. Everything is already an event. Take a deep breath and think about your day. When you woke up this morning, your alarm went off. That was an event. When you received a text message, that was an event. When you clicked a button on your phone, pressed a key, or even just moved your mouse across the screen, each of those was an event too. The beautiful secret is that the entire digital world works exactly the same way your life works. Things happen and other things respond. It's like a conversation, like a dance, like the way you naturally move through your world already. In programming, we have 3 magical words that capture this dance. On, emit, and want. These are not scary technical terms. We use the word emit to be cute, because it's an event emitter that we're working with. It's actually just send. They're just ways of describing what you already understand about how life works. When something emits, it's saying, hey, something just happened. When you listen with on, you're asking, when that happens, I want to do this. It means you are responding on an event. And on always demands that you specify the name of the event. And when you use want, also accepts an event name, you're just saying, just do this the first time it happens, and then you can relax and stop listening to that event. That's it. That's your first real programming concept, and you already understand it because you've been living it your whole life. On your left-hand side, you have on, some event name, and want, some event name. And on your right-hand side, you have emit, that passes the event to another emitter. Yeah. Now, imagine you're designing a simple system, like organizing a surprise party. There is someone who spots when the guest of honor arrives and announces it, right? There is someone who hears that announcement and turns on the music. There is someone else who hears it and dims the lights. Each person has one job, and they all work together to create something beautiful. This is exactly how we think in programming with events. We create little helpers that each do one simple thing well. That's called the Unix philosophy. One helper might watch for a button click. Another might take that click and turn it into a welcome message. A third may take that message and display it on the screen. Let me repeat that. One helper might watch for a button click. Another might take that click and turn it into a welcome message. A third might take that message and display it on the screen. So they are always emitting output and listening to input events using the on method. We call the first one a producer because it produces events. It doesn't consume them. A producer will send out something like, "A button was clicked." We call that middle one a transformer because it transforms one kind of information, a click, into another, a message. And we call the last one a consumer because it consumes the final result and does something with it, like showing it to you on the screen. You're building a network of helpers, each one simple and clear. On, some event name, give me data, and then emit, some event name with data. They all work together to create something wonderful. And you know what? You don't need to remember everything at once. You don't need to memorize anything. In fact, it's better that you look up documentation because people are usually expanding their programs. And you don't need to worry about variables or arrays or loops or any of the technical vocabulary that might have scared you before. All of that can come later, naturally, when you are ready for it. And again, because you are aware of the event emitter, of on and emit, and that there are variables and arrays, you just walk up to your favorite AI and ask it about it. Right now, though, we're just thinking about events flowing through your system like water flowing through a garden. One thing leads to another, and before you know it, you've created something alive and responsive. If you have a list of things that you want to work with, you can just have your producer send the list one item at a time, like dealing cards from a deck. Your system will handle each one as it comes, naturally, smoothly, and in order. You can add a mapping transformer that can upgrade that data, or you can add a filtering transformer that will drop a packet if it's not something you're interested in. Here is where it gets really magical. Because while event emitters are extremely powerful, sometimes some people build them out even further. Because everything in your system is an event, you can do something amazing. You can remember everything that happened and replay it later. It's like having a perfect memory of every conversation, every decision, every moment in your program's life, and now having the ability to project it at a new program that wasn't there when those events were gathering. This also means that if something goes wrong, you can rewind and not only see exactly what happened, but replay the data without any data loss. If you want to test something, you can replay the same sequence of events over and over. Just specify the sequence number that you want to start at, and sometimes just infinity as the end number, so that the system knows to replay all the events to the end. This is called event sourcing. It's a strange name, just as strange as event emitter and emit. They are cute names, loved by programmers. They are really powerful patterns. Event sourcing is not as popular as the event emitter, and some people avoid it because all those events pile up in your memory. But get this, you can take a snapshot. If your events, for example, describe a long profile of a single user, you can just collapse all the events up until now into a snapshot. Just create the profile and say this is the new starting point. Now you've cleared your memory. Event emitter is absolutely magical, but event sourcing is pretty good too. And you can make it visual too. One of the most exciting things about having producers, transformers, and consumers that pass events through is that you can actually draw your programs. Yeah, it's just boxes that represent the event emitters. Then on the left-hand side, you have input ports that represent the on some event, once, just to do something once. And then on the right-hand side, you usually have just one port, the output port. And then you can drag a line out of the output port into some port of another emitter, most often the input port. But say, if one of your emitters expects a color, then you can build up a little program that delivers some kind of a color to the color port of an emitter that has also the standard input and output. Instead of writing lines of mysterious code, which you sometimes can't read nor anybody else cares to, you can create pictures that show how events flow from one place to another, like drawing a map of a river system, something that's quite impossible to do in standard programming. There are visual programming tools all over, and they let you program by drawing, by connecting boxes with lines, by painting with logic instead of typing with syntax. And because you understand the flow of events, you're already mentally prepared to use those tools. Stuff just flows from left to right through boxes or ports. Here is something wonderful about learning this way, concept first as opposed to syntax first. The artificial intelligence understands this language of events perfectly. So when you want to build something, you can talk to it in natural language about what you want to happen. And AI will help you make it real. You might say, I want something that listens for when someone types in their name and then says hello to them. And artificial intelligence will know exactly what you mean. It can help you build the producer that watches for typing, the transformer that creates the greeting, and the consumer that shows it on the screen. You're not alone in this. Artificial intelligence is here. It can translate between your clear thinking and the technical details to help you build whatever you can imagine. And over time, weeks, months, maybe years, you memorize all the code because you're constantly exposed to it. You'll never get stuck, not with artificial intelligence. And if you ever do, then you just say, hey, let's just rewrite this program from the beginning. And oftentimes, it's a lot better than what you've been debugging. Everything becomes possible with the aid of artificial intelligence. Once you are able to visualize the event emitter in your mind, which is to say, understand it, the whole world opens up to you. You can build websites that respond to clicks and touches. You can create programs that process information and make decisions. You can design systems that talk to each other across the internet. You don't have to worry about how the event emitters are connected. But I'll tell you another tiny secret that you should not worry about right now. You should consider creating a connection agent. This means that the thing that connects ports together is somewhat intelligent. It can do extra things. It can respond to your needs even better than sending data directly into another emitter. Having a connection agent that binds the event emitter and the on is really rare in the standard world of event emitters. It's really meant for the visual programming world. This way, your line is as important as all the other event emitters, producers, transformers, and consumers. You can always ask artificial intelligence to help you build tools that make other tools, systems that create systems, programs that write programs, or event emitters that create other event emitters, which is to say, a producer that wraps an artificial intelligence that listens to your program needs and then can just produce all the event emitters, transformers that you need to make that program work. This pattern scales from the tiniest interaction on the screen to the largest communication between servers. Most complex applications use it every day. If you are new to programming, then let us close with your first real challenge. Are you ready to see this come to life? I'm going to ask you something, and I want you to know that there is no wrong answer and no way to fail, no reason to worry about looking foolish. The AI will take care of it. Open any AI assistant and ask this. Create a lightweight implementation of an event emitter in JavaScript. Then make a producer that emits the current time once every second. Make a transformer that takes each timestamp and turns it into the phrase, "Hello world." Make a consumer that prints that phrase on the screen, adding a new line each time. Wrap it all up in a simple HTML page, create the event emitter instances necessary to make the program function, and tell me how to open it in my browser. Then read what your AI gives you. Copy it into a file, open that file in your browser, and watch your first little event-driven program come to life. You'll see time flowing into transformation, flowing into action, and you'll realize that you're watching your own thoughts made digital. That is, after all, the source of all computer programs. The mind and thoughts. From this tiny, simple seed, you can grow anything. You can build apps and websites and tools and games and systems that help people and solve problems and create joy. The event emitter is superior to all the other programming components. You will always stand on the right side of history. When all the other senior programmers are having trouble reading and refactoring their code because the AI just can't understand it, because the AI just can't connect their craft together, because you can't see all the things that are implied because the programmers needed to make shortcuts, Your programs are just going to be boxes with well-marked input ports, output ports, and the lines connecting everything together. That's self-documenting programming, diagram programming. You will never be stuck. You will never have trouble reading your code. And you already have the mind for this. You already understand the patterns. Input ports, output ports, a box and lines that connect everything together. And the stuff that goes inside the boxes, AI will take care of that. You have artificial intelligence on your side at all times now. All kinds of assistants everywhere, ready to help you translate your brilliant ideas into working reality. The only question that remains is, what do you want to build first? Welcome to programming. Welcome to a world where your thoughts become tools, where your ideas become reality, where your creativity becomes unlimited. You begin now. Just pull up an AI, and there is no limit to where you can go.